right? We are looking at UTME 2011 physics. To be particular, we are looking at topic. The topic we are looking at is nuclear physics from 2011 Jamb questions, and the paper type is type C. Now we have the first question from number 41 in this type. The question is: a radioactive isotope has a decay constant of 10 raised to the power minus 5 per second. Calculate its half-life. A radioactive isotope has a decay constant of 10 raised to the power minus 5 per second. Calculate its half-life. Without wasting our time, we can easily see that this question relates the half-life of a radioactive substance and decay constant. Right. Of course, we now have to check out the relationship. We know that half-life is equal to natural log of 2 over decay constant, or we say half-life is equal to ln, that's ln of 2 all over decay constant, or when you find it from our calculator, is a constant. Ln 2 is what? Is actually 0.693. Okay, so we can say half-life, or we say half-life is equal to 0.693 over what? Decay constant. So that is the formula. So we're going to use this one. Natural log of 2 is 0.693. ln2, that's ln 2 is 0.693. So we're going to use that to find the half-life. The decay constant is given as 10 to the power minus 5 per second, right? So that means half-life is going to be 0.693 over the decay constant, which is 0.693 all over 10 to the power minus 5 per second, right? And then when we do that, it becomes 0.693 times 10 to the power 5, right? And that is what? 6.93 times 10 to the power 4 seconds. So that is the half-life. The half-life is 6.93 times 10 to the power 4 seconds. The correct option there is option A, right? The next question is in number 43, the same year, number 43. The next question on radioactivity or nuclear physics, rather, is number 43. If the threshold frequency for tungsten is 1.3 times 10 to the power 15 Hz, if the threshold frequency for tungsten is 1.3 times 10 to the power 15 Hz, what is its work function? What is its work function? Now we have the threshold frequency given. Now we are asked to calculate work function. Now this question, I repeat again, if the threshold frequency for tungsten is 1.3 times 10 to the power 15 Hz, what is its work function? Right, work function, this question relates work function and threshold frequency, or we say work function and threshold frequency. As a quick review, work function is also known as binding energy, right? And that's the minimum energy required, right, to liberate an electron from the surface of a metal, right? That is the binding energy, the minimum energy required to what? By an incident electromagnetic wave, precisely by incident light. Okay, photoelectric effect is the emission of electron from the surface of a metal by light that has sufficient energy, right? So, and for electron to be emitted from the surface of a metal, there is an energy binding the electron to that surface, and that is called work function. So the minimum energy required now to liberate the electron from the surface of a metal is called work function. The threshold frequency is a characteristic property of the incident light. Work function is a characteristic property of the metal. the threshold frequency, the characteristic property of the incident light. Why work function, the characteristic property of the metal. Okay, threshold frequency is just, when the photonic energy, that's energies from the light, is equal to work function. Now this frequency at which the energy of the light equals to work function is called threshold frequency. So an electron, a light that has energy equal to work function cannot give the electron what we call kinetic energy. Okay, so the electron will only be liberated, but it will still be on the surface, where it has been liberated from the metal, but it will still be in the surface because it does not have what? Kinetic energy. For electron that is ejected under photoelectric emission to have kinetic energy, then the incident light must have energy that is above what? At least a little bit above the work function. So let's now solve that problem that we have. So we know that our work function is equal to hf0, where this f0 is what? Threshold frequency. So threshold frequency to be what are we calculating? Sorry, we are calculating work function. Now we have the Planck constant as 6.6. We have from the question as 6.6 is a constant times 10 to the power minus 4, right? That is h, which is Planck constant. 6.6 times 10 to the power minus 34, right? Then times threshold frequency, which is given to us as what is the threshold frequency given? 1.3 times 10 to the power 15, right? Hertz. So if we solve this properly, we are going to get 6.6 times 1.3, then 10 to the power minus 34, that's minus 34 plus 15. So we have what? We have 8.58 times 10 to the power minus 19 joule. So that is a work function. That is a work function of the metal. Okay, that is the work function of the metal. So that is the minimum energy required for the electron to be liberated from that metal. Okay. Then we have the last question that we have is, under which of the following conditions do gases conduct electricity? We don't need to just go through a lot of things. Gases conduct electricity only at low pressure and high voltage. Low pressure, high voltage. Okay? So that's the condition under which gases conduct electricity in a discharge tube. Alright? That is it. At normal pressure, that's atmospheric pressure, gases do not conduct electricity. So the pressure has to be reduced appreciably. Then the voltage ranges from 1000 volts to 5000 volts, okay, before they can conduct electricity. Okay, once again, I want you to know that work function, which is the binding energy, is equal to hf0. Okay, now for electron to be liberated by an incident light from a metal to have kinetic energy, then the energy supplied by the light must be equal to work function plus energy required for kinetic energy. So kinetic energy therefore is equal to energy of the photon, that's from the light, minus what? Work function. In other words, if the energy of the light is equal to work function, kinetic energy will be equal to what? 0. Alright, kinetic energy will be equal to what? 0. So that is it. And also, I want you to know that work function depends on the position of the electron in the surface of a metal. The deeper the electron is from the surface, the larger the work function, the energy required to liberate it. So if the electron is very close to the surface, the work function will be small. All right. Thank you very much. You can always take your time to go through my blog again and see stuff that can help you in your preparation towards your exam. All right. Thank you very much. I wish you all the best. See you in the next video.